See this, a relation is said to be symmetric if x is related to y, then y is related to x through R for all x comma y belongs to A. That is, if the ordered pair x comma y belongs to R, then y comma x belongs to R for all x comma y belongs to A. So what they are trying to say is, we are going to apply or we are going to check if a relation is symmetric only under the case when x comma y is present in the relation. So if x comma y is present, then only we are going to check for y comma x, otherwise we are not going to check. Okay, probably with examples it will be clear. So this is somewhat difficult to understand. Try this. Let us say a equal to 1 2 3. Okay, and now assume that relation R1 equal to say 1 comma 2 and 2 comma 1. What do you think about it? Is this symmetric or not? It is symmetric because, see this, what is the definition of symmetric? If a element x comma y is present in the relation, then the element y comma x should be present. Right, which means if you have 1 comma 2, then 2 comma 1 is present, or if you have 2 comma 1, then 1 comma 2 has to be present. Yes, they are present, therefore this is symmetric. True. Right. So what about reflexive? Is it reflexive? I mean, we are not interested in that, but just since we are discussing about relations, it is not reflexive, right? And what about irreflexive? Yes, it is irreflexive, isn't it? Okay, now tell me about this. R2 equal to, let's say, 1 comma 1. Is it symmetric? Yes, it is symmetric because x comma y is present and y comma x is present. Therefore, it is symmetric. It is definitely symmetric. What about reflexive? Is it reflexive? It is not reflexive because all the diagonal elements are not present. Is it irreflexive? It is not irreflexive as well. It is not irreflexive because we don't have we are having at least one diagonal element, therefore it is not irreflexive. It is not reflexive, it is not irreflexive, but it is symmetric. Tell me about this. R3 equal to, let's say, 2 comma 3. That's it. Is it symmetric? It is not symmetric. The reason is, this is it is containing x comma y, which means 2 comma 3, but is not containing y comma x, which means 3 comma 2. In case if this would have contained 3 comma 2 as well, then we would have called it as symmetric, but it is not symmetric. What about reflexive? It is not reflexive. What about irreflexive? Yes, it is irreflexive because there are no diagonal elements at all. Tell me about this. 4 equal to, let's say, 3 comma 1 and 1 comma 1. See this, is it symmetric? It is not symmetric because x comma y is present, but then y comma x is not present, therefore it is not symmetric. Is it reflexive? It is not reflexive because all the diagonal elements are not present, all of them has to be present. Is it irreflexive? It is not irreflexive. Why? Because we have one of the diagonal elements. There should be no diagonal element if it has to be reflexive, right? Tell me about this. R4, R5. R5 equal to, let us say, here, R5 equal to empty set, which means it does not contain any ordered pairs. Is it symmetric? So what does the symmetric definition say? For every element x comma y, there should be the element y comma x present in the relation, then only it is going to be symmetric, otherwise it is not going to be symmetric. But here in this case, if you don't have any elements at all, there is no element called x comma y, then how are you going to check it? So the symmetric relation fails, which means a relation will not be symmetric only in case if x comma y is present and y comma x is not present. If both are not present, then it is definitely symmetric. So remember this empty relation is definitely symmetric, right? What about is it reflexive? It is not reflexive. Why? Because all the diagonals has to be present. Is it irreflexive? Yes, it is irreflexive. Got it? Therefore, the smallest set, the smallest relation which is symmetric is this one, isn't it? The smallest relation which is symmetric is empty set. Therefore, the cardinality of the smallest symmetric relation is 0. The cardinality of the smallest symmetric relation is 0, right? Now, what can you say about this relation R6 equal to A Cartesian product A? I am taking everything. If you take everything, right, then there will be two types of elements here, diagonal elements and non-diagonal elements. In case of diagonal elements, if you have all the diagonal elements, they are not going to affect this symmetric relation. If you have the diagonal elements, it is going to be symmetric, but then the elements which affect are non-diagonal elements. Now, if you have a non-diagonal element of type x comma y, then definitely the non-diagonal element of type y comma x will also be present in this set. Why? We are taking everything. That is why if x comma y is present, definitely y comma x is also going to be present, and so R6 is definitely symmetric, and in fact R6 is the largest relation possible. Therefore, the largest relation possible is going to contain, the largest symmetric relation possible is going to contain n square elements. Cardinality is n square. Got it? The smallest is containing 0 and the largest is containing n square. So only one thing you have to be careful while discussing about symmetric relation is, it is not that every element of type x comma y and y comma x should be present. It is only the condition that if x comma y is present, then y comma x is present, should be present. That is what you should be checking for. You need not worry if x comma y is not present at all. Got it? So in this case, see this. In this case, if this relation has to be symmetric, 2 comma 3 is present, but 3 comma 2 is not present. In case if you include 3 comma 2, then it will be symmetric. Got it? And you need not check about other elements like 2 comma 4 or 1 comma 2, something like that. Only when x comma y is present, you should worry whether y comma x is present or not. In case if it is not present, it is not symmetric. In case if it is present, it is symmetric. In this case also, you should worry only about 1 comma 3. Since 1 comma 3 is not present, that is why it is not symmetric. Got it? So in this case it is symmetric because 1 comma 2 and 2 comma 1 both are present, right? You need not worry about the other elements at all. Just be careful there. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.